The quadratic formula is a little bit like a bazooka. It solves any problem, but it's usually overkill. You got a rat problem in your house? Use a bazooka. Might be overkill. Boyfriend being mean to you? Bazooka would solve that. Might be overkill. Math teacher giving you a test tomorrow? Bazooka would solve that problem too. Please don't use that one. Welcome back to Calbeckistan, where anybody can learn math. My name is Mr. Calbeck, and today we're talking about the quadratic formula. I've written it up here for you. If you don't have it written down somewhere, this is a great thing to have in your notes. But I want to talk about what it is and how to use it, and hopefully once you guys are done with this video, you'll be able to answer any questions that you could possibly come up with. Okay, first thing to understand is the purpose of the quadratic formula. It looks terrible, right? That's what this is, by the way. This is the quadratic formula right here. This thing looks disgusting to anybody who's ever been in a math class. There's a big square root in it, all these weird symbols. But we want to talk about the purpose of it today. And the purpose of the quadratic formula is to find the x-intercepts of any parabola. And I do mean any parabola. And I'll show you why real quickly here. If you have a parabola and you wanted to graph it on your xy axis, what we're looking at here is your x-intercepts are these points. And they're going to be at a coordinate. Each one is going to be somewhere on your graph. This one, maybe this is at, we can put in an arbitrary grid here, so we can actually talk about this. But this one right here maybe is at 2 on the x-axis, but that coordinate happens at 2, 0. This one over here would be at 3, 4, 5, 6, 7. This one would be at 7, 0. And I hope what you've noticed about this, and this is true for any graph of any kind, parabola or not, that the x-intercepts always occur when y equals 0. That's a really important idea. And so the way the quadratic formula works is it takes advantage of that feature. What you do to find the quadratic formula is you set a standard form equation, which normally is equal to y. You're going to set the y equal to 0, because we know that the x-intercepts happen whenever y equals 0 on the graph. And due to some fun math that I'm not going to show in this video for the sake of time, what you can do with this is you can complete the square on a generic standard form equation and then solve for x. If you guys are interested, leave a note in the comments. I'd be happy to do a video on exactly how to do that. But once you solve for x, you have x here. And notice, the only x in the quadratic formula is right over here. It's what x equals, and what it stands for are the x-intercepts. The rest of these, the a in the equation is the same as the a in the standard form. The b in the equation is the same as the b in standard form, and likewise c. I've color-coded it for you so you can see that really easily. And so whatever your equation is, all you have to do is plug whatever number is in here in your standard form into your equation for a, whatever number is here in for b, and whatever number is there in for c. And it will give you the x-intercepts. Again, any parabola. All right, so the quadratic formula, please use it as a last resort. If factoring and completing the square look too challenging, only then resort to the quadratic formula, because it's always faster and easier to use another method first. So be careful with that. Right here I have a quadratic. If I wanted to graph it, I would need to know the x-intercepts. So I think this might be a great opportunity for the quadratic formula. It doesn't look like it's going to factor. All I need to do is to set the y equal to 0, and I have a situation like I've got over here. So real quickly, you can see that there's a number here in front of x squared. That is going to replace the a. The b is a negative 8, so I'm going to replace the b with that. Because it's a negative, I'm going to change this plus sign to a minus sign as well. And the c is negative 4. Likewise, I'm going to change this c to a negative as well. So this is going to become a negative 4. Be really careful as you do that. Those signs do matter. And now what we're going to do, we're going to plug each of those things into the quadratic formula, and we're going to solve it and see what we end up with. So we'll start with the b. It's a negative. That's part of the equation. So I put that in black so that you know that. So when I put a negative 8 in here, there's a negative 8. So be careful of that one. Likewise in this, it's a negative 8 squared. This one doesn't matter as much because negatives squared are positives. The a value is positive, so it becomes a positive 8. And the c value is negative 4, so I'm replacing the c with a negative 4. All right, the only other thing we need to fill in is the a down here, which is the same number as above. That doesn't change. All right, so now we've plugged in our quadratic formula. If you find yourself putting an x anywhere in this equation, you did something wrong. There should never be an x in there. The only x is right here. Please be aware of that. If you see an x in your equation, you did it wrong. This is all numbers. No variables. So we can simplify a couple of things. So I've got negative 8. That's a negative right there. So negative and a negative actually make a positive 8. So I'm just going to cancel that out real quick. Negative 8 squared becomes a positive 64. And over here we've got some multiplication. I have a negative 4 times 4 times, so negative 4 times 8 times another negative 4. That's, if you put that in your calculator, ends up as a positive 64. So be careful, that means I'm going to add this. 2 times 8 makes 16. Now we can simplify a little bit more. I'm going to finish what's inside the square root here. So 64 plus 64 makes 128. And at this point, all you can do is start to simplify what you've got. So the square root of 128, you probably type that into your calculators. Some of your teachers are going to want you to simplify that square root down. You can do that if you want to, but I think for this video, let's just stick with the calculator. The calculator version of square root of 128 is 11.31. And we're almost done here. Notice there's a plus or minus here. What that means is there's two equations. So there's one version of this where it's all plus. So I have 8 plus 11.31 over 16. And there's another one where you have a negative. So it's 8 minus 11.31 over 16. You can type both of those into your calculator. You're going to end up with 1.366 and negative 0.366. You should expect to see two answers most of the time in the quadratic formula because there's two x-intercepts in most parabolas. So you should see two answers. And again, the x is still there, so it's x equals two different numbers. Please write your answers like this. I'm going to show you a couple other ways you can use the quadratic formula to help you graph parabolas and find some other interesting features. All right, I've rewritten the quadratic formula here. I want to show you another way that you can use this. This is a big fraction. It's in two parts though. It's kind of like this fraction is dividing the square root, and it's also dividing the negative b. So if you split this up into two fractions, what you see is you have negative b over 2a, and this whole thing over 2a. This part right here is really useful this is the equation for the line of symmetry in your parabola. Now again, remember parabolas have this sort of U shape to them. The line of symmetry goes straight down the middle of the parabola and always intersects the vertex. So if I want to find the vertex, I want to first find the line of symmetry. And I plug in the same parts of it. So negative b, that's this negative 8. It's the same part of it. So it's negative 8 over 2a, which is 2 times 8. We can simplify this down. You end up with positive 8 over 16, which reduces to 1/2. And again, this is x equals that. So that means the line of symmetry is going to be at x equals negative 1/2. Now, if you remember from your linear unit, when you're graphing a vertical line, your vertical line is an x equals equation, because it's plotting every point where x equals that number, where all of the coordinates that are x equals negative 1/2. So x equals negative 1/2 would be right here, and right here, and right here. So my vertical line is my line of symmetry right there. Now I know, because it's a parabola, that the vertex lies somewhere on that line of symmetry. So all I need to do, if I want to find where that is, it might be down here, I don't really know where it is, but I know that it's got a coordinate, and the x-coordinate is 1/2. I don't know the y-coordinate yet. If I want to find the y-coordinate, I plug that back into my original equation and solve for y. You're welcome to do this as well. You can plug this in, so you have 8 times 1/2 squared minus 8 times 1/2 minus 4. And you can do this on your calculators pretty quickly. But we'll do it the old-fashioned way to make sure we get it right. So 1/2 squared is 1/4 minus 8 times 1/4 is 4 minus 4. So I have positive 2 minus 4 minus 4, which means my vertex is going to be at negative 6 with a x-coordinate of 1/2. So I can use the quadratic formula to find the line of symmetry and eventually use that line of symmetry to find the vertex. All right, one last piece of the quadratic formula that you can use is this other part of it. We don't actually care about the 2a. I only care here about the square root part of this. Now what this is going to tell me is there's 3 possibilities here. I could be taking the square root of a positive number, I could be taking the square root of 0, or I could be taking the square root of a negative number. Those are the 3 possibilities. If you want to know an interesting thing about your parabola, you can tell just from this part of it how many x-intercepts it will have. This part is called the discriminant. The discriminant tells me how many x-intercepts I've got. So if I use my equation here, I can plug this in, and we found out earlier that there was negative 8 squared times 8 times negative 4. And what this ended up giving us was the square root of 64 plus another 64, which is a positive number. And we saw that the positive number gave us 2 x-intercepts. And the reason for that, when you look at a parabola, wherever it is, if you look at the line of symmetry, essentially I'm going to be adding a number to the line of symmetry to find 1 x-intercept. I'm going to be adding something to the line of symmetry, or subtracting something to find the other x-intercept. So I'm going to be adding a piece and subtracting a piece. If this number is greater than 0, then I'm going to have 2 x-intercepts. So this is greater than 0, square root of 128. It's positive, it's going to be 2 x-intercepts. If it comes out to be 0, that means I'm going to be adding 0 to this and subtracting 0 from this, which means that my x-intercepts are basically the same point. It would look something like this, where your line of symmetry goes there, and there's no distance between the line of symmetry and your x-intercepts. So here, this is only going to give me one x-intercept. The last case is the weirdest case, where I have no x-intercepts. You can try, you'll find that there's parabolas that have 0 x-intercepts, and they're floating above the x-axis, or maybe hanging below it, but at no point do they ever intersect the x-axis anywhere. You'll see that if there's a negative number in here, maybe -4, something like this. If you end up with a negative number in your square root, you can't take the square roots of negative numbers. So far as you know, stay tuned to Algebra 2, you find out that you can do this. But for right now, this is impossible. Since we can't actually compute it, this tells me that I'm going to have 0 x-intercepts since I can't get an answer. So again, a positive discriminant tells you there's 2, a 0 discriminant tells you there's 1, and a negative discriminant tells you there's 0 x-intercepts. All right, that's all the cool stuff I know about the quadratic formula. If you have anything you'd like to add to this or another video that you'd like me to do on this, please leave that in the comments. Be happy to help you guys. Look forward to seeing you when I get back.